All right, so up next, we'll continue with the data analytics and machine learning. We have Nick Werstiuk from IBM. He's going to be talking about the challenges involved with scaling Spark in an infrastructure. Nick's going to introduce himself, so we'll let him move forward. Thanks for listening.
Thanks, Arno. Good morning, everybody. So first of all, let me introduce myself and my role within where I live within the small organization of IBM. So I am Director of Offering, Management, and Strategy for the software-defined infrastructure products within the systems group. And so I am ex of the platform computing acquisition into IBM. So I have history, about 15 years history in this space from an infrastructure software perspective. And I've also most recently managed the Spectrum Scale or GPFS product in sort of a converged platform and spectrum scale opportunities. So what I'm going to talk a bit about today is probably very different than the previous presenters, is because I'm going to talk about the interactions that we have with our large enterprise clients as they look to deploy Spark in their environments. And this is hopefully illustrative of some of the things we're seeing, informative for you to kind of have a different perspective on the things that we're seeing and the interactions we're having with these clients. And so tried to boil this down into, I guess, 4 key challenges from our perspective, right? And I'll take you through those. And let me just start by sort of taking a step back on the frame of reference. So the kinds of clients that we're talking to are obviously starting to really embrace Spark as an analytics framework to rewrite or to introduce new applications. And those organizations are generally large enough that they want to build a private cloud like Spark environment inside their infrastructure. And that's the fundamental kind of starting point of this. There's lots of public cloud options for the deployment of Spark, right? Databricks has a service, IBM Bluemix has a service as well. But fundamentally what we're seeing is there's still a lot of interest in setting up that Spark-centric shared environment inside a large enterprise. And so that's the frame of reference of what I'll talk to. I'll sort of put some conclusions on the board about the choices that people are trying to make in this and how that infrastructure is going to work. And I can speak to the evolution required for HPC. You know, HPC has a big definition, or technical computing, as Earl and Steve talk about. You know, we have a lot of clients across a lot of industries doing a lot of design, simulation, and modeling on scale-out infrastructure, which I'm sure everybody, you know, some of it through MPI and parallel workloads, some of it high throughput computing on similar types of infrastructures. And so what we see is some, and we also have a set of clients doing large-scale dynamic service-based analytics applications in financial services. And so there's a lot of similarities to some of the challenges we've seen from the Spark workloads. And actually, we've brought a lot of the experience that we had in the high-performance analytics space in financial services to the Spark workloads to make them deliver the most effective Spark environment for a large client. This is not a product pitch, hopefully, except I have one slide at the end. Had to have the obligatory product overview slide. So what is Spark? I don't know if I needed to put this chart in here. I did put it in here. And as IBM, right, and there's lots of IBM activity around Spark, and I'll just kind of frame it. We see this as a very strategic and very important analytics framework for next generation analytics, right? And it supports a lot of different application workloads and a set of libraries on top of the core foundation of Spark. It's a lot faster because it brings the calculations and the data into memory, and it's got a big ecosystem developing. And if you look at the ecosystem developing between the large players and the communities, there's a lot more investment going into Spark as a community than there is in the traditional MapReduce and Hadoop spaces. So we, obviously, from our perspective, right, there's, as I said, lots of activity and interaction around Spark in the IBM organization, right? Our analytics group has created a Spark Technology Center, committed to introducing value add and contributions to Spark in general. Our contribution from the group I'm in is really around enabling people to take Spark and run it and build a shared service environment for Spark. So think of, again, dreaded cloud word, but think of a private cloud Spark environment inside the firewall of an organization. And so to deliver that, we are seeing these 4 sort of key areas of challenges. And It's hard to convey this notion of diverse users and applications in a simple slide, but fundamentally, the kinds of clients that we're talking to, the problem statement that we're hearing about is they have dozens, hundreds, maybe thousands of scientists and data scientists and analysts who want to run Spark workloads. They also have a range of Spark workloads. They want to have batch workloads. They want to have interactive query through notebook workloads. They want to do streaming workloads. And fundamentally, that is creating a challenge, right? That typically in organizations, the line of business folks or the end users like to create their own silos and their own environments, and they like to deploy those and kind of control and manage their infrastructure for their use case. And what we're trying to avoid, and what we're trying to help our clients, or the challenge we're trying to help clients address here, is this ability to support the multiple groups, multiple lines of business, with the different types of end users, with the different application types on a shared Spark infrastructure. And so that's kind of the one challenge we see. And we see this, I'll be honest, in some of the more progressive firms who are ahead of, let's say maybe on the early stages of the curve, having several hundred folks wanting to start to run Spark applications in a production way at a large scale on a wide range of data sources. But they're trying to get to this vision of supporting any and all users and applications on the shared infrastructure. The second point of view that we hear a lot about, and it's driven by diversity of the workloads and the applications and the users, is the challenge of dynamic and agile. And because of the patterns and the characteristics of these different workloads, some are longer running batch workloads through Spark, some are short-running stream workloads, some are query workloads through notebooks. There's a challenge in trying to make sure that that environment and that infrastructure is optimized to be dynamic and agile to use those resources in the most effective way to meet the needs of all the users. And so, the charts here, one of the ways we're trying to help or work with clients and work with this client feedback is propose a set of more real-world benchmark use cases for multi-tenant shared Spark environments. And so we proposed this SMB1, Spark multi-tenant benchmark, ran a couple of different scenarios to kind of give some variability of running multiple types of workload or multiple user workloads on a shared infrastructure, and then had produced a report in terms of the variability of the job execution distribution across all those workloads. Trying to get to, can this infrastructure supporting multi-tenants be reliable for all the different users and workloads? Can I deliver that kind of agility to the business? And that's kind of one of the areas that we hear a lot about as a stepping stone if you're going to support those multiple user workloads in multiple user groups on the same infrastructure. So the next step in that path, in terms of the challenge, then is how to do that all cost effectively and delivering SLAs to the clients. And this boils down to a lot of clients that we're dealing with live on this borderline between the end users wanting a certain behavior and the IT group trying to deliver that certain behavior to their end users. And there's a lot of pressure in that model for the end users wanting control and a silo and the management of their own infrastructure to deliver the service level they expect. And what we're hearing from clients, and I don't think this should be any different or news for a lot of the for the HPC world, right, is to deliver a shared infrastructure that can run these workloads and get rid of the silos, right? And the silos really come in both the users, the applications, and also the data side, right? And this picture kind of is a high-level view of saying, look, the silos are not where you want to go for this kind of, where clients want to go for this kind of cost efficiency. They need a model to manage the resources effectively and then deliver this kind of behavior across multiple applications where they're getting efficiency of using those resources, right? And the other part of that cost efficiency is the ability to use the right resources at the right time, right? So not having expensive resources that might have certain types of different characteristics, but putting all those into the resource pool and making those available for the cost-efficient execution of those workloads. So the last challenge we hear a lot about as we talk to our clients is, and I think some of this already came up in the multi-data center, multi-data source discussions earlier today, and the notion of multiple frameworks. And so what we're hearing and seeing, obviously, is that people might start with a Spark environment, but then they have a whole set of other frameworks and applications that they want to introduce into that same shared infrastructure or cloud-like environment. And each of those workloads has a set of characteristics. Some are long-running services, some are short-running services, some are container-based, some are service-based, but the ability to then extend that Spark environment to support multiple kinds of frameworks and applications has been something we continue to hear about as being critical for enterprise clients. The data and storage management piece, we see a lot of interest in evolution of this layer because of the fundamental question, right, is when I get to this Spark or deliver my Spark shared infrastructure, we sort of see this as a continuum of resource types that are going to be introduced into or managing this infrastructure for clients. At one end, right, traditionally, the Hadoop world has gone with a storage-rich, co-locate the storage in the compute server model. At the other end, most of the HPC organizations that we've seen have gone more to a compute and memory-rich model and use network-attached storage or network-based storage to access the data. And what we're seeing, right, is kind of clients trying to figure out what the right architecture. Do I start with my current Hadoop HDFS storage-rich environment and layer this Spark infrastructure on top of that current data? Or do I just access that data as an input source and bring that in and set up a Spark-centric environment that's compute and memory-rich to take advantage of the fact that Spark is going to run in memory and leverage the compute resources? Right, so that's kind of one of the challenges we see from our clients, is trying to figure out how to expand the frameworks, address the kinds of infrastructure choices that are coming, and then expand the approach to how that data is going to be persisted or introduced into the Spark-based applications. So that's the four kind of key areas that we're having conversations with clients about as they think about this architecture to support Spark. And we do see a range, right? We do see some clients who are thinking, okay, this is just another app on my Hadoop big data cluster, right? And we see clients heading down that path, right? We do see clients who are saying, that's a waste of money because now I've got a bunch of storage-rich servers that I don't really need to run compute and memory-bound problems, right? So we're seeing kind of a trade-off between clients trying to make those decisions on the architecture and the approach they're going to use. So that's the four main ones, but I wanted to put in a couple other ones that we are pretty actively seeing and trying to address and work with clients on. The first one is many of the workloads in Spark benefit from GPUs versus CPUs. We're actually, one of my colleagues is presenting at Spark Summit on some of the GPU scheduling stuff that we've done, so that'll be on in June. And so we're seeing a lot of interest, right, in how to effectively blend the workloads of Spark onto a CPU, GPU environment and have the capability to be smart about moving the workloads back and forth depending upon the SLAs and depending upon the requirements of the applications and the workloads. The second area that we're seeing a lot of interest, we've done some initial prototyping on, is reusing the memory in-memory data sets, right? And being efficient about allocating applications and not having to reload data into memory all the time. Right? I think I saw something on one of our charts somewhere that said in a TerraSort, 37% of the time is waiting for the data to get loaded into memory to run the TerraSort in Spark. And so if we can be smarter about the workload mapping to the data sets for the users, then we can achieve overall throughput and efficiency and address some of the challenges that clients are telling us about today. So that's kind of the perspective on some of the additional challenges we're seeing. And then finally, a couple of conclusions, and then, as I said, one obligatory product slide, and I'll go through that quickly. So the cloud model, the external cloud model, is forcing many of our enterprise IT organizations that we deal with to think about how they deliver a cloud-like experience inside their firewall. And I think that's not new for anybody in here. But fundamentally in the Spark space, that's the experience that we're seeing our clients want to get to, right? How do I take that build a shared service for my data scientist inside the firewall on the data that lives inside my firewall, and do that in a cost-effective manner to manage my business. And this notion of flexibility for personal kind of dedicated environment, we see more and more variability. Bring your own libraries, bring your own applications, bring your own frameworks, bring your own stuff in Docker containers to be executed. And we see all of that be part of the challenges that clients are trying to address in this shared environment. The performance and SLA for the clients we're dealing with become really critical, right? If you're gonna operate that internal cloud-like service for Spark applications as a shared service, then you better be able to do it cost effectively. You can't waste resources, and you can't waste SLA time to wasting resources, meaning that if you have to commit resources and make sure certain high priority interactive workloads get the resources they need and get the throughput they need, then that's the way you have to operate the infrastructure. And the idea there is to always, I'm pretty simple in the way I describe this and the client expectations. The clients are looking to us to help either the business make money or IT save money. And it really boils down to those two things, right? In the line of business, folks don't really care about saving money. They care about writing the applications and the analytics and running their workloads and driving the business benefit for the firm. The IT guys are balancing how to deliver that in a cost-effective way. Because in our world, historically, and I'm sure it's consistent, the other expression I use is we see demand as infinite and unpredictable from the users, and supply eventually is fundamentally fixed. You can go to a cloud and flex up and take advantage of all sorts of cloud resources, but somewhere along the way, your budget is gonna limit your supply. And eventually, you have to make some tough decisions to deliver service levels about how to manage the workloads and those resources. And then finally, this whole ecosystem is moving crazy fast, right? So we see every, 6 weeks, a new version of Spark, multiple notebooks, and this lifecycle management capability inside this shared service is critical to deliver an effective shared service that's gonna deliver that flexibility of kind of make this look like a personal dedicated environment for the users, but give you the flexibility to sort of scale that and manage that in an ongoing way. So that's kind of the challenges and the conclusions. And just, I dread to do this, but so from a product perspective, we've packaged up a set of these capabilities into a new offering. It's a combination of open source and value-added components from us. And fundamentally, we're trying to deliver that shared Spark service infrastructure capability inside the firewall for our clients. So thank you for your time, and hopefully that's okay, Steve, in terms of timing. If there's any questions, happy to take any of those.
All right, any questions for Nick?
Yes, how do you decide when to upgrade your hardware?
So the clients, IBM's running a cloud service for Spark. I'm primarily in the software element of it, right? So the net of it is, right, is we live on top of heterogeneous resources. So we see clients running on x86, of course. We see clients interested in Spark on Power because of the additional capabilities that Power brings. And so, I think over time, we expect if a client starts building this kind of shared infrastructure, it's not, I'm gonna buy 1,000 nodes tomorrow and then I'm gonna load all these people in. It's gonna evolve over time, so different processor models, different resource types will come into the mix, and you need to be smart about how you can best use those resources to support the applications, right? And generally our clients are on the client side, I'd say their massive replacements are in the three-year time frame, I think. They sort of amortize out over 3 years. But it's not like everything goes every 3 years. It's kind of continues to grow.
Steve?
Uh-oh.
How expensive is it, Spark adoption? If somebody doesn't use any Spark and all of a sudden they start contemplating Spark, what do they got to think about for budget?
I think like all these adoptions, the applications and the workloads drive that adoption, right? So the clients we're talking to have grabbed on to Spark as a key piece of their infrastructure, right? So we're not really driving Spark, hey, Spark's great. we're working with people who have recognized the need or the want to move to Spark-based applications or deploy Spark-based applications. And then we're providing a solution to the problem they're going to have to deliver that in production in a reliable way. Right, so that's the scenario that we're seeing.
Yeah, you said that people are expecting the same experience that they have on a public cloud. Are you seeing more customers who have internal data centers moving to this thing, or are they coming from public clouds and they want to bring it internal?
So most of it is, so I can speak to what we're seeing from adoption with IBM, right? So you go to Bluemix, there's a tile on Bluemix Spark service, right? And basically, data scientists can go and run Spark applications on demand on the IBM cloud. And that's managed by our analytics group. What happens is that analytics group is promoting that to lots of clients and lots of end users, and that triggers a reaction to say, for many institutions, right, yeah, I can run some of it in the cloud, but all my data's here, and I got private data, blah, 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 all that stuff, right? So now it becomes a question of, I've got 300 data scientists inside the firm, how do I create that environment internally, right? And that's partially I think that's a big part of what we're seeing as a use case.
I can make just a small comment that at PayPal itself, we're doing a fairly fast shift from Hadoop to Spark. Like you said, it's fast crazy, which is unbelievable how fast the technology's changed, or the thinking of how people are doing analytics. But we're also marrying it with Kafka because of the streaming analytics part of it. So between the two technologies, we're getting a huge advantage for real-time streaming analytics out of Spark.
Thanks.
Anyone else? Great, let's thank Nick for a
guys.
great talk.
Thank you.